Unit 10, Light Energy. Section 2, Spectrographs. Page 10. Main ideas. Different types of light sources emit different ranges of light. Light waves can be reflected, refracted, or absorbed. A spectrograph is an instrument used to measure the range of light emitted or reflected by a light source. Why use fluorescent lights? Fluorescent lights are the long bulbs of light hanging from the ceilings of most public buildings. They shine a harsh white glow on the objects and people below. These lights make up in cost what they lack in beauty. Fluorescent lights are cheaper to use and waste less energy in heat than other light bulbs. Incandescent light bulbs waste more energy because they use heat from a filament to produce light. In comparison, fluorescent bulbs are filled with gas atoms that become charged with energy when electricity passes through. The gas atoms release this extra energy as light, but not heat. How does light travel? Rays of light travel in all directions from a source. Each ray travels in one direction without stopping until it bumps into matter. Once light meets a surface, it is reflected, refracted, or absorbed. Light that bounces off of a surface is said to be reflected. The amount of light a surface reflects depends on how much light it absorbs, and whether the surface is smooth or rough. Black surfaces absorb more light and reflect less light than white surfaces. A flat surface, like glass, bounces light in the opposite direction it travels, allowing you to see your reflection. The bending of light as it travels through a different object or substance is called refraction. You can see light refracted by mediums such as water or a prism. A medium is a solid, liquid, or gas substance that light waves travel through. Light slows down as it refracts, causing it to travel in a new direction. What is a spectrograph? Every type of light source emits a different range of wavelengths. It is possible to identify whether a light bulb is fluorescent or incandescent by using a handheld spectrograph. A spectrograph uses a type of finely scratched plastic called diffraction, grafting to refract light. The grating causes light that enters the spectrograph to bend and separate into the unique colors, wavelengths of light that make up the light source. Scientists use more expensive spectrographs on telescopes to identify the elements that make up stars. The sun's spectra, shown below, shows that it is mostly made up of hydrogen, with a bit of helium and heavier elements mixed in. We will be doing the spectrum activity in class together. Section 2. Try this on your own. Observe. Look at many light bulbs at home and at school with the handheld spectrograph. Warning, never look at the sun with the spectrograph. Are there any light sources that emit a different spectra than fluorescent or incandescent lights? Reflect. Study your own light use habits. Pay attention to how many hours a day you leave your lights on at home. To conserve electricity and lower your family's energy bill, always turn lights off when you leave a room. Diagram. Study the room you are in. Where are the light sources? Draw a scientific diagram that shows light waves being emitted from each light source in all directions. Where do the light rays meet? Where are light rays reflected, refracted, or absorbed? Write. Write a persuasive essay arguing which light bulb you think is better for lighting the classroom. Incandescent or fluorescent bulbs. Fluorescent bulbs waste less energy, but are less pleasant to look at. Incandescent bulbs are less harsh, but use up a lot of energy to produce a little bit of light. Glossary. 1. Absorption. The transfer of light energy into heat energy when a light wave meets a surface. 2. Electromagnetic spectrum. The range of light energy from radio waves to gamma rays, separated by wavelengths and frequencies. 3. Light, a form of energy that is carried by waves through space. 4. Light wave, a pattern of light energy that moves at a constant speed until meeting a surface. 5. Reflection, the bouncing of light off a surface. 6. Refraction, the bending of light as it travels from one medium into the next, for example, from air into water. 7. Spectrograph, an instrument used to measure what range of light waves are emitted or reflected by a light source. 8. Visible light, the middle range of the electromagnetic spectrum that can be sensed by the human eye, ranges from red light to violet light.